Hello, I'm Soo-Lyn Choi of the Department of Computer Science and Engineering at Dongguk University, who will present the paper, A Study on the Efficient Offloading Method based on Asynchronous Virtual Machine Code Execution. I'm gonna start the presentation now. The table of contents of this presentation is as follows. Chapter 1, Introduction, introduces the background of this study and the problem to be solved. And Chapter 2, Related Studies, introduces the related research. In Chapter 3, I will introduce the asynchronous-based offloading technique that we want to propose in this paper. In the last chapter, Chapter 4, Conclusion, I will introduce the conclusion of this paper and future work and finish this presentation. As I mentioned earlier in the table of contents slide, the first chapter of the presentation, Introduction, introduces the background behind this study. With the development of fifth generation internet technology, the amount of software used has gradually increased and requires more computing resources. In line with these changes, edge computing technologies have emerged to reduce server deployment costs and increase the efficiency of the services provided. With the advent of edge computing technology, it is possible to stably provide services at a low cost of building servers from the perspective of service provision. However, for edge computing, there were problems due to the relatively low performance of edge nodes. Offloading technologies have emerged to address these problems. But offloading technology is used to process an operation that is difficult to process in a client in a cloud server. However, the existing offloading technology has a problem called blocking state. This problem occurs because the client must synchronize with the server and the client must wait in the interrupt state until the server returns the operation results. In this paper, we try to solve the problems existing in these offloading technologies by proposing asynchronous-based offloading techniques. This is second chapter, related studies. The first of the related studies is offloading. Offloading is a technology that reduces the load on clients by passing tasks from clients, which are edge nodes, to servers within edge computing systems. This technique delegates tasks to cloud servers that are relatively high performance compared to clients, and only the results are returned to the client. With this technology, the service can efficiently handle tasks that require high performance and computation, regardless of the performance of the edge node. However, this offloading can cause delays due to network overhead in the process of delivering tasks from clients to servers. In addition, traditional offloading techniques create a blocking problem in which the client waits without processing any tasks when offloading occurred. A simple model structure diagram for offloading technology is shown in figure 1. The following related studies are the instruction reordering technique. This is a technique for reorder the order of instructions within a software program. This technology allows you to change the order in which software programs are running. For programs that apply instruction reordering techniques, the execution results are the same as before this technology was applied. This paper attempts to change the order of programs executed within clients by function and uses this technique to solve the problem of blocking by placing independent variables using the offloading technique applied above. The next chapter is the technique that we would like to propose in this paper. The technique to be proposed in this paper is offloading method based on asynchronous virtual machine code execution. In this paper, it is assumed that the unit in which offloading proceeds is a function unit. First, a profiler based on deep learning technology is used to determine when offloading occurs. At this time, the deep learning models which is used are graph-based